have KNIME on your desktop. Let me know once it's done. In the meantime, I'm also giving you a simple data set.
Sir, can you please confirm, like I have shared a screenshot. Is it the right software that I'm using? 9.
uh, uh, yes, yes, yes.
Okay.
Correct. So,
Thank you.
yeah. Anybody else who has Usha Makrand? I have also uploaded a data set in the Teams. Let me give it here also in the chat. You can download this data set. It's a very simple data set to demonstrate a classification problem.
Shall we open this into
Yeah,
application?
yes, we will. So, but I just want to check if others have been able to download.
Yeah, done, sir.
Okay, done. Great. So, we'll open KNIME. Let me first open KNIME and your version may be a slightly newer version than mine. That should not cause any problem because unless they have made any major change, it should be okay. So this is the first screen. Okay, I will.
Yes, sir. Same.
Yeah, got it. Great. Okay, so see, classical way of solving machine learning problems is you have to code in certain popular coding languages like Python or R. And that's why many people are very scared of data science, because if I am not coming from a coding background, that becomes a stumbling block. And I'm very scared that, okay, data science is something related to coding and I can't make any headway into that. And as a result, what happens is that after all, when you are making digital strategies for an organization, remember one thing, digital, as by now you would have realized that all the digital technologies are by definition technical areas. Okay, it is not like a very generic area like a sales and distribution or advertising or something like that, where you can take management decisions based on more common sense. Okay, so something like sales and distribution, even advertising, even for that matter, marketing are pretty commonsensical. There is no great theory or technology into it. So that's why it is easy for somebody to pick that up even without a technical knowledge and be a manager. But that doesn't apply for anything that is to do with technology. Okay, whether you talk about something like a right, by technical subject, I don't necessarily mean um, software or something like that. Technical subject is anything that requires deep knowledge. Okay, so medicine is also a technical subject, technology is also a technical subject, legal is also a technical subject, finance is also a technical subject, but sales and distribution is not. Okay, unless you are kind of doing analytics on sales and distribution. So whenever this comes for technical subjects like technology, it is very difficult to take managerial decision unless you are yourself quite sound on technology. Okay, unless you have known technology, is you cannot take technical decision. You cannot take decisions. You cannot define a strategy based on common sense. So that's why those of you who are kind of getting into leadership roles or planning to get into leadership roles, you have to have a fair understanding of technology. Now, what does this fair understanding mean? Like many of you would be saying that I don't come from an IT background, I don't know coding. So is it possible at all for me, or we are just wasting time? So what has happened today is most of these softwares, they have become productized, they're packages. So you don't really need to know coding as such to understand this as a technical subject like machine learning. But you do need to understand certain statistical concepts, which is relatively easy to understand if you have, let's say, some amount of science or mathematics in your up to your class 12. It is not very difficult to understand basic statistics. Okay, so as long as you have that, even if you don't have coding, you should be able to do this. So that's the whole purpose of giving you exposure to this tool. So as a business manager, let's say you want to identify use cases or opportunities of machine learning in your organization, and you want to build a prototype on this, this is an excellent tool to do that. Okay, so that's the reason I'm showing you this. Any questions before I proceed? All good, everybody?
Yes, sir.
Great.
Yes, sir.
Yes, sir.
Okay, so now see this Naim, what we'll do, we will see what we are using is a free version of Naim. Obviously, when you use these tools in enterprise level, they are much more, much more rigorous. They can handle much bigger amount of data, and obviously these are licensed. Okay. But most of the features that we'll be handling now will be available in this free version as well. So we will create a local space. Okay, so here if you go, click here, it will come to this space. For you, probably you will not, you will have a blank or you will have this example workflow, only this much. Okay. You will not have anything else. Okay. Or maybe my workflows. Okay. Maybe example workflows or my workflows. These are only two folders. This is like folders. This is the place where we are going to build our model. Okay. So it's best to create a new folder. So if you, that's just like creating a normal folder in File Explorer. So I can just create a new folder and just call this, let's say, bits. You can give some other name, whatever name you choose. And now anything that you do will be inside this folder. Okay. So far, fine. Have you been able to create your folders?
Yes, sir.
Yes, sir.
Right. Now, if I click over here, under this folder, we will create workflows. What is a workflow? Workflow is essentially the steps that will be required to achieve the desired objective. Okay, now what is the desired objective? Now, if you open the data set, I'll just pause here and I'll go. If you can just open the data set that is uploaded, which is a diabetes data set. A very simple data set.
Yeah, sir, the view seems to be a bit different. I'm trying to
Okay.
figure it out.
Okay. No problem. Let me, if you, is it possible for you to share your screen? I'll just show you.
Sure, 1 second.
So are we,
No,
do we need to do
I
import
don't have
workflow?
the.
Yeah, we'll come to the
Okay.
Sir, I don't have the right to share.
sharing option. Okay. Let me check. Right. Usha, right? Make a presenter. I'm making a presenter. Okay. Now you will be able to share.
Um, can you see my screen
Yes, come.
now?
Yes, no, I didn't see your the NIME interface.
Okay. No, I'm trying. Is this okay? Because
Yeah.
it
No,
went
no. No. So so this, yeah. So now you are going to create the workflow. Okay. So what you have done is that you have created a workflow in the root folder. Okay. So you are in the
Okay.
same screen. Okay. You are in the same screen. So you have created a folder in your name and now you are going to create a workflow. Okay. So we don't create the workflow now. Let us understand what we plan to do and then we'll create the workflow. Okay.
Okay, sure. All right.
Okay, so we need to, as business managers, we need to be clear about what we intend to. Okay, but we don't need to know coding. So what do we intend to do? If we look at this data set, let's assume that this is data about whether a particular patient is diabetic or not. There are certain attributes. So pregnancy, glucose, blood pressure, skin thickness, insulin, how much insulin level or something like that, BMI, okay, some diabetes, pedigree function, age, and then, so these are my features. These are my features. And then the outcome, though it doesn't clearly say what is 1 and what is 0, but let us assume 1 means somebody is diabetic and 0 means somebody is non-diabetic. Okay, so this is the data that is given to us. Correct?
Yes, sir.
Yes, sir.
Okay. Now, I think last class, did we discuss about physics-based model and data-based model, data-driven model, this concept, the difference between these two concepts?
No.
Okay.
No, sir.
Okay. See, I think I mentioned maybe, so when we talked about regression, the height and weight, remember we discussed that there's a velocity like a v equal whatever,
V equal to u plus 80.
Yeah, V equal to U plus AT. That is a physics-based model, right? That means if it has a definitive answer. If I know the U and you know the A and T, V, there'll be only one answer of V, and there can be no other answer. On the other hand, let's say if I try to find out height, weight from height, there is no one formula that will give you height, weight as a function of height. Okay, there's no one formula. You can have a set of data, and based on the data, you can find out what is the most probable weight given the height. Most of the medical problems, if you see, are also like that. It is very difficult to create a formula that I mean, I can't create a formula given these features, and this formula will tell me whether somebody is diabetic or not. And that is why I mean, what is the difference between a good doctor and not so good doctor, or experienced doctor or not so experienced doctor? They are able to find out some relationships. So it's a tacit knowledge. Most of it is a tacit knowledge. Okay, they are able to find out some relationship between all of these factors. And of course, they understand what diabetes pedigree means. We don't understand what diabetic pedigree means. And based on that, they are probably able to say that somebody may be diabetic or not diabetic. Okay, that's the whole idea of that's how you identify a good doctor. Now, the whole idea is that can the machine imbibe that implicit knowledge? If I give a set of data, a reasonably large set of data, can a machine try to find a relationship between this and say whether somebody is diabetic or not? That's the whole idea. That means I am trying to replace the tacit knowledge of a doctor with a machine-based or data-based knowledge of an algorithm. Remember, it's not a physics-based model, it's a data-based model, which essentially means that I have to, if I have to build this, I have to have past data. This is where many organizations fail. If I look at from a digital strategy perspective, if you have to implement, let's say these are medical case, let's say I'll show you another case and maybe I'll ask you to do that. That's an industry. I want to predict whether a machine is going to fail or not fail. Same kind of thing. So supervisor has that tacit knowledge that some people worked in factories, they know that there will be some supervisors who can even gauge the sound or the vibration and say that this machine is going to go down, because that's the tacit knowledge they have. Somehow they implicit have created the relationship. But can I bring that knowledge into the machine? Okay, so same kind of things. But then the most important thing is that I have to have past data and enough amount of past data, because if I do not have enough amount of past data, the model will not be able to train itself correctly. So I should have enough amount of past data. We'll have the data of all these features. We are calling these features those factors that are driving the target. What is the target here? Outcome is the target here. So I want to predict that outcome based on these factors. Okay, and I do not have any formula. I can't make a formula, but I have data, and I'm asking machine to create some kind of relationship. Okay, so that I can get the outcome. But I need to train the machine with past data, which shows what are the values of the respective features and what was the outcome. And given this data, the machine will first train itself. But how do I know that the machine has been able to train itself? It's like study and examination. This same data I'll divide between two. One data I will give to the machine to train, where I'll give the values of all these features as well as the target. And the other one, I will only give the values of the features, but not the value of the target, even though I have the value. Even though I have the value, okay, but the machine, the model will not have that value. The model will tell me whether the outcome is diabetic or not. And then because I have the value, I'll compare. It is like, you know, I have a model answer and I compare what answers the examinee has given and say how much the answer is correct or not. And if the answer is correct to the level of accuracy that we desire, then we can say that the model has been trained. And once the model has been trained, then if I give a new set of data where I don't have the outcome, this outcome is not known. Remember this out here, the outcome is known. Somebody has already said Maybe a doctor has already said that this guy is diabetic, this guy is not diabetic. Now I don't have the doctor, but I have this data. And I want the machine to say that whether somebody is diabetic or not. This is the objective that we are going to, this is our objective that we want to achieve. Okay. First, let me know if this is clear.
Yes, sir.
Yes, sir.
Okay. Now, with this objective, all that I have to think is logically, how do I proceed with this objective based on certain principles of statistics and mathematics. Okay. I don't need to know coding, but I need to know the steps. Okay, what I should do, because the coding will be done by KNIME. So KNIME will have certain small packages which has code written inside it. Okay. All that I have to do is I have to invoke those packages, and those packages invoking is dependent on the steps that we intend to. Okay. So if it is clear, let me proceed with the package. So, and you can do it along with me. Okay. So that is called the workflow. These steps are called a workflow. So I will create a workflow. So I'll call this workflow, let's say, diabetes prediction.
Sorry, sir, your screen is not visible.
Okay, sure. So here you have this plus symbol, and here you go and say diabetes prediction. Immediately you will see that this kind of screen will open where you have some nodes, some colorful block boxes over here. These are called the nodes. Nodes means that these are inside these, there are some codes which we don't need to see or we don't need to know. But let's say if I use this node Excel reader, internally what will do, it will pick up a file that I want it to pick up and read the file. Now, while we don't need to write a code, I need to provide some inputs for the code. For example, obviously, if I want to read a file, then I have to say where is the file located? What is my directory? Okay. Otherwise, it doesn't know where the file is. So similarly, there are certain configurations, and we call these configurations. There are certain configurations that that you need to do in this process. Okay.
Sir,
But
can you please
before-
repeat this step?
Yeah, sure. So okay. All I did was I was in this folder.
Mhm.
And let's say you have created a new folder, and in this new folder, you have to create a workflow. So this is where you create a workflow. So where you have to give the name of the workflow. So for me, it is diabetes prediction. And once you create it, it will automatically be directed to a screen or the canvas where you are going to build your workflow. So here, if you click over here, so when you're creating it first time, it will be directed to this space. So let me know if all of you are in this space.
Yes, sir.
Done, sir.
Okay, so now we have to just think logical. Now, first tell me, based on what we discussed in the last class, what the types of problems, etc., the machine learning problems, the regression and those kind of things. What kind of problem is this? We talked of certain type of problem like regression, classification, clustering, time series. So what
This
type
is
of
more of a
problem? are you
logistic problem.
It's
Sir.
more
This is a yes or no
regression.
problem.
Sorry, one by one.
So this is a logistics problem because we are trying to see if a person is diabetic or not. So there are two choices only at the output. Either you have a yes or a no.
Yeah, but do not confuse between a model and a type of problem. Okay, what you are talking about is the model. I think you are talking about logistic regression. Okay, that's a model. Okay, that's one of the models for a particular type of problem. So what is the problem?
Clustering,
What type of
because
problem?
you have to
It's the type of
clustering
problem is
because
regression because based on the data you are finding, try to find the model out of it?
No, I did not get what is it? I think 2-3 people were trying simultaneously. Yeah, Ravi, goes please. Yeah.
So is it a regression type of problem we are going to
No.
solve, because based on the data we are
It will,
try to creating the model?
Okay.
it's
Okay.
a
Let me
cluster.
take a
It's
view
a,
of Usha. Yes, Usha, please go ahead.
is it clustering, sir? Because you are trying to find out the grouping of the people, whether they are diabetic or not
Okay.
diabetic, depending
Okay.
on the result.
Okay. 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 Ravi says regression. Usha says classification. I think Avinav previously mentioned that it is a logistic regression, which is more of a model, not a type of problem. Makran, do you want to? I think I saw Makran trying to say something.
Yes, sir. It is a classification whether the person are diabetic
Yeah.
or not.
Yes. Okay. Makran is among the three is right. It's a classification problem. Okay. Avinav is right in the extent that you can use logistic regression model, okay, for classification, and we'll see whether which more type of model is more accurate, etc. But the problem that we are talking about here is a classification problem, because say why it is not a regression problem. Okay, regression problem gives you an output in terms of value. So if I were to predict the amount of, let's say, sugar or something like that, based on certain parameters, I'm trying to predict the amount of blood sugar, which is a value, then that will be a regression problem. Okay, but here I am trying to say whether a person is diabetic or not diabetic. I'm trying to classify whether a person is diabetic or not diabetic, and not trying to say how much, what is the sugar level, etc. However,
Got it.
yeah, sorry, Ravi.
Yeah, understood, sir. Yeah.
Yeah. And to be more precise, it's a binary classification problem, because in this particular case, we are trying to classify into two classes, either diabetic or not diabetic. Okay, there can be multi-class classification where I may want to classify at 3 levels. Let's say there are different type of diabetes, we know. So let's say there are 4 types of diabetes. So which type of diabetes? Okay, if I wanted to classify like that, then it will not be binary classification problem anymore. However, I'm making one statement here, and I'll explain this statement, or rather I'll ask you why I made this statement at the end of this exercise. Okay, the statement I'm making is all classification problems are essentially regression problems. So note down this statement, and at the end of this session, I'll ask you that why did I say this? Okay. Even though we are talking about regression problem is different, classification problem is different, and this is a classification problem, still I'm making a statement that all classification problems are essentially regression problem, and I ask you why I made this statement. Okay. Usha said that it is a clustering problem. Okay. Now, why it is not a clustering problem? It could have been a clustering problem, provided I did not have any training data. So clustering is a unsupervised learning, where I would have given, let's say, 5 different parameters, glucose, whatever, okay, age, etc. And I have got, if I had told that, can you group the patients into, let's say, 2 clusters, such that the patients within a cluster are most similar to each other for among these parameters, whether it's age, glucose, etc. They are most similar. Whereas the patients who are between 2 clusters, they are most dissimilar to each other. So here I am not passing any judgment that whether somebody is diabetic or not diabetic. I'm just saying that group them into 2. Another easy example to understand, I'll come back to this cluster, this thing, but just let me explain a little bit of clustering, because this is one of the, I think last class I did not cover clustering and time series. So both of these, just let me quickly cover what is the what is clustering and what is time series. because then that will cover 4 basic machine learning models. Okay. So clustering is, let's say, same problem of height and weight. And if data points of height and weight, and I have different data. Some data over here. Okay, now last class, what we are doing in the regression problem, we said that I want to predict weight based on height. So can you give me a line? Can you give me a line or you know, a polynomial, whatever, so that so that if I know the height, I can get the weight to the best possible accuracy. Okay. But this time I'm not saying that. This time what I'm saying is that I'm saying that can you group these points into, let's say, 4 clusters. I have defined the number of clusters already. I have defined the number of clusters already. Okay. And I'm saying that can you group these points into 4 clusters such that the observations within a cluster are most similar to each other and the observations between clusters are most dissimilar to each other. Okay. So what does it mean? It means that if I take this as a circle, so if I take this, let's say this group. Now this group, the values will have a centroid. Centroid means the distance from this point with all other points, the sum of the squares of the distances should be the minimum. That's the centroid. So if I can create 4 such groups, and I don't know how will I create these 4 groups, but I have to create these 4 groups in such a way that each of them will have a centroid and the distance of each point from the centroid is the minimum, but the distance between the 2 centroids is the maximum. Then what will I get? I will get a group of 4 clusters, or I'll get 4 clusters where observations within the cluster are most similar to each other, observations between the cluster are most dissimilar to each other. Let me know if this concept is clear.
Yes, sir.
Okay. Now the problem is that, as you can understand, I have deliberately put these points like this because, as you can understand, it's not easy to find out those clusters. Okay. For example, I don't know whether this will be forming a cluster, whether or these points will, or maybe my cluster should be like this. Instead of this, my cluster should be these points. I should make a cluster. I don't know, because you know, visually I cannot calculate these distances. So what is this model doing? This model is calculating these distances mathematically. That means it's trying out all options, all possible options of these, grouping together the points. And for each option, it is trying to find out what is the sum of the distances from the centroid to individual observation and what is the distance between the cluster. And by multiple iteration is arriving at a situation where these 2 values are optimal. That means the square of the distances from the centroid to each observation within a cluster is minimum, and the distances between the centroids of 2 clusters is the maximum. Once that is achieved, once the objective is achieved, it has created 4 clusters where observations within the cluster are similar, but observations between the clusters are most distant. This is called clustering.
Sir, but
Is this
how
clear?
model will get to know how much clusters are there?
There are techniques of knowing. There's something certain thing called elbow methods and all, by which you figure out initially how many clusters you should create. There are methods of doing, but that will get into code data science. Okay, so I'll not be able to probably discuss that because that will be, too mathematical and getting too deep into data science. But yes, possible to find out what is the optimum number of clusters that you should have given a data set.
Okay.
Okay. Now, one significant difference between clustering and classification and regression, between clustering on one hand and classification and regression on the other hand, is clustering is an unsupervised learning. An unsupervised learning. So here you are not talking about giving a data set and giving an answer, asking the model to find out the relationship and get trained with the data set as given, and then later on giving another data set and asking the model to predict on that data set. That is not the case here. Here I'm giving the model one data set and I'm asking the model to cluster them into 4 clusters. Okay, so there is no unknown prediction that I'm doing. I'm not first giving a known data set and then giving an unknown data set and asking the model to predict on the unknown data set. There's only one data set here, and I'm asking the model to cluster that data set. That's why it is called an unsupervised learning. Clear?
Yes, sir.
Now the last one, which is called time series. Time series is essentially a type of regression where we are looking at only one feature, which is time. So let's say I want to predict the stock market. Now I can do a prediction of a stock market purely based on time. That means how the stock market has performed in the past. Whatever, let's say you want to predict the Sensex. So how is the Sensex moved in the past? Based on that, on the time, I am trying to predict how it is going to move in future. So this is my prediction, but this prediction is based only on what has happened in the past. That is time series. Time series theorists argue that any factor that is affecting the stock market will automatically get incorporated into the time, unless that factor is something called a black swan event. Black swan event is an event that has never happened in the past or happened very rarely in the past to have got incorporated in the time series. Black swan event, for example, COVID is a black swan event. Ukraine war is a black swan event. Okay, but so such black swan event, in case of black swan events, these days stock market predictions are done on other factors, not just on time. For example, the tweets will indicate that whether there is a possibility of a war in future. And based on that, it is going to predict if that is going to have an impact on the stock market. So because the black swan event, that type of war has not COVID, or for example, COVID, that has not happened in the past. But the tweets will say that people are saying that this is going to be a very big human catastrophe. There will be lockdowns, etc. So the system will take those tweets and incorporate that in predicting the stock market. However, that no longer then becomes a time series problem, that becomes a regression problem. Okay, but those kind of regressions obviously is not as easy as height and weight, because here we are talking about text data. And there you have to use more sophisticated models. There are sophisticated models like RNN and LSTM and various other, now of course large language model, etc. is coming. Okay, so which is much more sophisticated to understand what people are tweeting about and then predict. But otherwise, if I just go by the time, then this is a time series problem. So most machine learning problems in the industry are one of these types. One is regression. Second is classification. Third is clustering. And fourth is time series. Machine learning problem. Deep learning problems are of different types. Deep learning problem, there you were talking about computer vision, trying to predict the defect, taking a picture and trying to predict a defect, right? Your Digiyatra, okay, that's also machine learning, but that's I mean that's not the classical machine learning. That's more of deep learning. Okay, so far fine, everybody.
Yes, sir.
Great. So now let us go back and we will now build that model. So we have a file here. The file I think is a CSV file, right? It's a is it a CSV file or an Excel file?
Sir, CSV.
CSV file. Okay, so we need a package that will read the CSV file. It cannot be an Excel reader. So let's see if we have a CSV reader. We have a CSV reader here. So you just drag and drop this CSV reader. This has to be the first step. Because first, if I have to do anything, before doing anything, I have to read the file from wherever I have stored it. So just drag and drop this CSV reader into this canvas. Okay. Now we have to do a configure. So if you see there are three lights, red, amber, and green. Red light means that this particular node, these are called nodes, and inside this node there are programs. This node is not yet configured. That means if you run this node now, there'll be errors. Nothing is going to happen because it doesn't have the right input. So I have to configure. In order to configure, right click and you will see that there's configuration. So if you go to configure, this opens a screen where there are options to configure this particular node. Now, in the interest of time, I'll just go through some basic configuration. Okay, but it tells you that how much deep it is. Okay, but your objective is not to be a data scientist as such, but you should know how these tools are used. So I'll go into the basic one. So here it first is saying that from where will I read the file? So in our case, it is in our own computer. But in enterprise scenario, the data may not be in our own computer. Data can be in an ERP system or maybe in a cloud database. So most of these enterprise grade have these options to mount the data from some other sources as well. But as of now, we are taking from a local file system. So and then go to browse, and wherever your file is, are you able to see the screen, the pop-up? Yes, no?
Yes, sir.
Okay, great. So go to browse and you pick up the file from wherever you have saved it. Okay, so you can see that it has read the file, okay, and it is intelligent enough to understand the first row. First row is actually a header row and just put in a header. And if by mistake it is not able to do that, then you can see here there's a tick has column header. And from this, it will, if this tick is on, That means it understands that the first row of the file that is reading is essentially a header column, and it should not be considered as a name, okay, as a value. Okay. What we need to do one more thing. If we go to this advanced transformation, there is something called a data type. Data type is nothing but whether a particular value is numeric value, like you can in numeric value there can be integers, there could be decimal, or the value is something like a string value. Okay. Now, if you see here that outcome, it is taken as an integer because the value is 1 or 0. But actually, what is this outcome? Outcome is nothing but saying that whether somebody is diabetic or not. So the value of 1 is just indicating it's diabetic. So it is not a number actually. It is actually a string that represents whether somebody is diabetic or not. There is no meaning of 1 plus 0. So if I take this as number, then this will not give me the right result, especially the kind of problems that we're trying to solve. So what we should do, we should change this to from number to string, which is S. Only then this will work. Okay.
Sorry, sir. Can you repeat the step actually?
Yeah.
I'm
So
still in
no problem. No problem. So just see this outcome is indicated as integer. Instead of integer, you should make it a string, because actually this 1 and 0 is not any number which you can add. Okay. It's not like blood pressure or skin thickness. It is indicating that somebody is diabetic or non-diabetic. Only case is the indication. Instead of saying diabetic or non-diabetic, it is indicated by 1 and 0. So 1 and 0 is not considered a number here. They are basically showing some class. So that's why 1 and 0 can remain, but this should be considered as a string value rather than a numeric value.
But how did you get this dialogue?
Are you able to see this dialogue? You go to the transformation tab. So on the top,
okay,
there's a transformation.
Okay. No, got it. So string. Text.
Yes, that's. Everybody fine?
Yes, sir.
Okay. So now, if we don't need to make any other changes, as of now, we don't need to make any other changes. We'll just say apply and OK. The moment we say apply and OK, you see this has become yellow, which means that this particular node has been configured correctly. If it is incorrect configuration, it will become red. And all that we need to, but now still till then the file has not been read. Okay, till the file has to be read. If you have to read the file, have to execute it. So there's something called execution. I can also right click and get execute. And moment I execute this, what is done is that executed the file, and now down below you will be able to see all the file, and in fact you can see the outcome in form of string. Let me know if this is fine.
It's done, sir.
Yes, sir.
Right.
So far it looks somewhat similar to what we do in R at RStudio. I mean, reading the file, loading it in the.
Yes, but only thing is in RStudio, you have to write your commands. So if you are not a coder, two things. One is if you're not a coder, you are having a little inhibition. Here, you don't need any coding knowledge. Okay, you just need the basics of machine learning and you can do it. The second is that this is easier to present to management.
Right.
Okay. So when you are, let's say, identifying machine learning or a data analytics opportunity in your organization and you want to build a prototype, if you open an R script and show to the management will not be interested. But if you show this pipeline, any manager will be able to easily understand what exactly you're doing.
Yeah.
Okay. So that is the advantage. Okay. Now that you have read the file, usually what happens is that the data is not absolutely clean. What do I mean by clean? There is possibility that some of these data points have missing values. For example, for some reason, one particular person do not have data about skin thickness. In fact, here also you'll see there are some zero values here. We don't know whether these zero values are actually missing values or it is really zero, because we are not domain expert. Okay, but a domain expert may say that, look, the value of insulin cannot be zero. This must be, this data is not there, it's missing values. Okay, so, and that's where so today what is happening is that as a domain expert, you have to have the knowledge of data science to provide this kind of input to the data scientist. Because the data scientist doesn't know that whether insulin should be, is it a zero is a valid value or it's an invalid value. Only a doctor will say that there is nothing called zero insulin. Okay, this has to have some value. If it is zero, it means that somebody has not entered or that the machine was which captured the insulin value was not there, whatever. Okay, so then the treatment will be different. What do I do with this? So that's one type of this is called pre-processing. Okay. Similarly, there can be another situation where two different values are strongly correlated to each other. Remember, we are not talking about correlation between the features and the outcome. We are talking about a correlation between two features, let's say glucose and blood pressure. If both glucose and blood pressure are highly correlated, and others are not that correlated, then what is going to happen is that one particular type of feature is going to dominate, I mean, these two features which are highly correlated will dominate the model, because these two features is like they are playing like a team. These two features are playing as a team. Okay, so then you have to do some other type of pre-processing. Okay, so there are certain pre-processing that needs to be done. For now, I'm assuming that this data is clean and it doesn't require any pre-processing. Okay, so I'm not doing any pre-processing, but usually any data will require a lot of pre-processing. In fact, probably the maximum amount of work goes in the pre-processing and deciding what kind of pre-processing is required. Okay, so far fine, everybody.
So are we, so in this case where the values are missing, are we going to remove those rows as a cleaning process?
We are not doing anything for this. Okay, for this particular exercise, we are not doing anything. Okay, because that's an involved exercise. We have to figure out whether removing the rows is right or not. Okay, if removing, because if there are too many values where insulin is zero, then if you remove the rows, a lot of data will go away. So then the question will come that if we don't remove the rows, what value should we put? Okay, then we have to think of, can I predict the value of insulin? Before I predict the outcome, I have to predict the value of insulin based on others. Or should I take, let's say, a median value? Or should I take a modal value? So there will be certain statistical analysis that we have to do before we decide what to do with the missing insulin values. In reality, when you are doing a data science project, those things have to be done. Otherwise, your accuracy will be very low. But for now, I am ignoring this. Okay. So far, fine, everybody. If you go to the statistics tab, it will show you some important statistics. For example, for each of these numeric values, what is the minimum value, what is the maximum value, what is the 25% quartile, 50% quartile, 75% quartile, what is the mean, what is the mean absolute deviation, what is the standard deviation, etc. Okay. And of course, outcome has now been converted to a string. Previously, it was a number. It has been converted to a string. So obviously, there is not there's nothing called a minimum value or a maximum value. So 1 and 0 is no longer 1 is greater than 0. 1 means diabetic, 0 means non-diabetic. Okay. So far, fine, everybody.
Yes, sir.
Great. What do you think we should do next? Assuming that we are not going for any cleaning, assuming that this is good enough for cleaning, what do you think you should do next?
We should give one sample value and then check whether the predictions are correct or not.
No, first I have to build the model. The model is not built.
Okay, sorry.
Sample value will be given to see whether the prediction is right or wrong only after we build the model, right?
So then build the model is the next step.
Yeah, but building the model consists of multiple steps.
So first
Build
of all,
the model, what should we do? Okay, first of all, tell me what I mean. We have heard about, let's say, so it's a classification problem, right? So what are the models that the basic two models that we have discussed in classification?
sir, logistic regression and decision tree.
Logistic regression and decision tree. Can you tell me which one should be used here? Prima facie. We'll do both. Okay, we'll do both, but prima facie we'll see which one should be done, and then once we do both, we'll compare the models and see which one model is better. And we'll see whether our assumption is right or wrong. So out of logistic regression and decision tree, which one prima facie appears to be more appropriate?
Sir, we can use logistic regression here because all the features are quantitative data.
Very good. Absolutely. Absolutely. So remember that if all my features are quantitative values, which in this case it is, usually logistic regression works better than decision tree. Okay. Because logistic regression is an equation, whereas decision tree is an if-else statement. For a numeric data, let's say glucose, a decision tree has to split glucose less than this, greater than this. Now, what is less than, what is greater than? So it can be less than 100, more than 100, can be less than 150, more than 150, it can be less than 150, less than 50, more than 50. So there is no clear differentiation point. On the other hand, if the values were categorical values, let's say age group, instead of age, it was age group, which then becomes a categorical value. Or let's say instead of pregnancy, it was pregnant or not pregnant. That will become a categorical value. So if it is a categorical value, then usually decision tree performs better than logistic regression. In fact, a pure categorical, if it is a pure categorical value, you cannot apply logistic regression unless you do something called an one-hot encoding in preprocessing. Because if it is a categorical value, you cannot write an equation. You cannot create an equation for the value. Because these values are not numeric. You can create an equation only for numeric values. Okay. Is this concept clear? Let me know if any concept is appearing uncomprehensible. Okay. Because as I said that to take decisions on digital strategies, your basic understanding of the technology and the science is very important. Great. Now, if we use decision tree, if we use logistic regression, there is one important thing that we need to do if the values are in different scales and different units. You see glucose, blood pressure, skin thickness, BMI, they're all numerical values, but they are having pregnancy, number of pregnancies. They are in different units and they're in different scale. So pregnancy, the higher the gap between highest and lowest value may be let's say the lowest may be 0 and highest may be 10, for example. Whereas glucose, the highest can go up to 210. It's a different unit of measure. But when you're writing the equation, y equal to m1 x1 plus m2 x2, okay, there is no unit of measure here. This is just a numeric value. So do you think anything needs to be done, or we can straight away take all the values in our logistic regression model?
So normalizing our input features will help.
Very good, very good, very good, excellent. We need to normalize the features. So let me, let me ask: has everybody understood this concept, or should I explain this? Because these are very, very important concepts. Okay, there's no harm if you don't understand, because these are specific mathematical concepts which some of you may not be comfortable with. So tell me if you have not understood. I'll explain. Anybody feels I should explain, or everybody is comfortable?
Comfortable, sir.
Okay. Great. Fine. So we will do our normalization. Now, normalization would not have required needed if we had a decision tree. Because in decision tree, there's no equation, it's if else. So it doesn't matter which unit of measure it is or which range it is. But it is normalization is required for logistic regression. So now you need to one way of finding the node is you can just go by this is input output node, is manipulation node, fuse node. So these are all these different types of node, and some nodes are shown here, others are you have to just say show all and it will show everything else. Okay, and this is so one way is just you can just go and scroll, but it's quite a tedious job. So best is to search. Okay. And the keyword that we'll use for search obviously comes with little bit of experience. So if you say, I am hoping that there is something called normalization. I want to see the input node. Okay. So here you see normalizer. Okay. So just let me know if all of you have found this normalizer node. Everybody fine?
No, sir. I'm not getting that normalizer thing.
Okay, no problem. I'll help you on that. So who was that? If you can just share your screen. Was
This
it
is
Ravi
Abhinav.
or Avinav? Okay, okay, right. Just make your presenter.
Sir, I tried to search in the nodes.
Yeah.
Or in
It's
the
a
manipulation node, do I have to search?
No, don't worry. Don't have to select manipulation. Don't select anything. Okay, just go and select. Just search normalizer. Yeah, just
normalizer, sir. I'm not getting it.
Yeah, go to this. So you have on top a filter setting. Okay, on top right hand corner you see there's change filter settings. So now you just make it all nodes. Yes, make it all nodes and then apply. Now
okay, normalizer.
Yeah. So basically there was a filter that was set. Yeah. So anybody else who is facing the same problem should do the same thing. Okay. So I'll bring the normalizers here, and if you see that there will be a node, in any node there is usually an input and an output. Okay. Sometimes there is some other node, okay, normalized model, etc. In this particular case, I will not use this. Except some of the nodes which have only output because they are the starting node. Now all that you need to do is to connect the node. You have to click the left mouse and just drag it and connect it over. So that's how the workflow is getting connected. So essentially we are saying that read the file and now normalize it. And of course we have to do some configuration here before we can actually run it. Click over here. What do we want to normalize? We want to normalize. So note that here the outcome value is not there. Outcome value is not there because we have defined outcome to be a string. A string cannot be normalized, right? Only a numeric value can be normalized. So wherever it is integer or double, those values are there. Now, if we want to normalize everything, we will leave it like that. Suppose we want to normalize, we don't want to normalize as a pregnancy, then I'll just put it on the left hand side. But this case, we do want to normalize pregnancies, so we'll keep it on the right hand side. Okay. There are different normalization techniques. As of now, we will just go for min-max normalization, which means that every value will be compressed between 0 and 1. That means every value will have a scale of 0 and 1. So then there'll be no question that pregnancy is only between 0 and 10, and glucose can go from 90 to, let's say, or 80 to 200. So that difference will not be there. Everybody okay so far?
Sir, I'm not sure if the dialog for normalization has half viewed for me. I cannot see the green side.
Okay.
Yes, it's the
Same
same
here,
for me.
same.
Okay.
Okay. So let me just, you can just share your screen, Usha.
No, whatever you were showing, sir, from
Oh,
your
acha,
screen, we are not able-
whether you saw this dialog blocks. Okay. Yeah, sometimes the dialog blocks are not always visible, so they just show
Okay.
that. Okay. So now can you see configure?
Yes. Yes. Yes.
Good.
Yes, sir. It's all same. So
Is it okay? Okay, fine. Yeah.
Yeah.
So we are normalizing everything except the outcome. Okay, so we just apply and we are doing a min max on normalization. That means the value will be between 0 to 1. So say okay, apply and execute. Once we execute, I now can see that my data, all the data, if it's pregnancy or glucose, insulin, whatever, except the outcome, everything has now been converted in a scale of 0 to 1. That is it. That means it is unit of measure agnostic. Okay. Correct. So now what we need to do is, remember we said that we need to have two data. In one data, we'll train the model where we will give all the values, all the features, as well as the outcome, so that the model is able to frame the equation. In case of logistic regression, the first equation will be y equal to mx plus c. So in this particular case, if there are 5 features, m1x1 plus m2x2 plus m3x3, m4x4, m5x5 plus c, and then convert that to logistics, z equal to 1 by 1 divided by 1 plus e to the power minus y. So it has to frame this equation. Now, if you are just to frame this equation, I have to give some data such that the error, the equation is such that the error from the actual value and the value predicted by the equation, the sum of the squares of the error is minimum. And then what I'm going to do is I'm going to give another set of data where the answer is not given, but the answer is known, and ask the model to predict the answer and then compare the answer given by the model with the answer already available and see how much the model is accurate. Correct? Everybody fine so far?
Yes.
So, but we have only one data set. So what we need to do is we need to divide this data set into two. One data set, we are going to, one of the divisions, we are going to give it to the model where with all the values, both the attribute features and the target, and get the model trained. The other set of data will leave for testing the model. This process is called train test split. You split the data between training data and testing data. But there are certain things that we need to be careful about while splitting into train and test. But first, let us take this train test split node. So what we'll take a node called partitioning. See, there's a node called partitioning. Take this node over here. You will see that the partitioning node has one input and two output. Why two output? Because we are trying to divide the data into two different sets, one for training, another for testing. The top one will be the partition 1 and the bottom one will be partition 2. It is up to us which one we treat as training and which one we treat as testing. Normally, the training data set will have a higher volume. For example, 70% of the data may belong to the training data set and 30% of the data may belong to the testing data set. Everybody clear so far?
The first set is training.
Yes, sir.
Yeah. We will use the top one, the first one for training and the second one for testing. So we'll connect.
By default, it is 70% for, by default,
Sorry?
it is 70% for training, right?
By default, it's 70% for this. So yeah, we'll keep by default 70%. Sometimes it's 80-20 also. Okay.
Okay.
Now, if you go over here, configure, as you rightly said, that by default. So first of all, we don't want to do absolute, because absolute means that you take an absolute number of values for training and remaining values go for testing. But here we want to take a relative. That means whatever means the number of observations, 70% of them will be using for training and remaining 30% will be used for testing. Sometimes you also take 80-20. Usually the industry standard is either take 70-30 or 80-20. Now there's a very important thing, sampling. Which 70%? I have 100 points. Which 70% will go into the training and which 70%, which 30% will go into testing. Now there are options, but the option that needs to be used here is something called stratified sampling and stratified on outcome. Can anybody, guess kind of what this might mean? And why is this there?
Is it finding homogeneity in the heterogeneity?
Okay, and what exactly you mean by homogeneity?
When you are comparing two independent variables, like these data, so what is the homogeneity between them, or what is the heterogeneity between them, actually, based on that stratifying the it's actually we learned in QM subject.
QT, QM, quantitative methods.
Yes,
Yeah, quantitative method. Okay. Okay, maybe you are meaning the same thing, but let me explain you what exactly it means. Is stratified sampling enabled? Yes, it should be enabled, Usha.
Not connected. I reconnected. It worked.
It worked. Okay. Okay. So let me explain what exactly it is. It means and why we are using this. See, we are having a data set where, let's say I have 100 observations. 100 observations. And we are trying to divide these, or let's say 1,000 observations. We are trying to divide this between 2 samples. One sample is the training, which consists of 70% of the data. That means 700 should be here. Another is testing, which should consist of 30% of the data. And here it is, let's say 300. But this 100 itself is divided into 2 classes. One class is diabetic, another class is normal. Let's say the diabetes class consists of 100. That means out of 1,000, only 100 are diabetic and 900 are non-diabetic. Now, what if it so happens that all these 700 that I have sampled, all of them become non-diabetic? Correct? If all of them become non-diabetic, 700 become non-diabetic and 0 become diabetic, and remaining out of 300, 200 become non-diabetic and 100 becomes diabetic. Then what is going to happen? Will the model get trained correctly?
No, sir.
No, because the model, the data that has been given to the model has no case which is diabetic. And the model will not be able to find the relationship. And when then you try to test the model where cases are diabetic, it has no clue what should happen. It's like setting questions from outside the syllabus. So ideally, what should happen? Ideally, the 700 should have the non-diabetic and diabetic cases in the same proportion as the population. This is my population. And this is my sample. Sample should have both the classes in the same or at least close ratio as that of the population. That means if 90% is diabetic, I should have 19 to 7, so 630 should be non-diabetic and 70 should be diabetic. And here I should have 270 non-diabetic and 30 diabetic. That's how I should be dividing the sets. This is called stratified sampling. And when you are doing stratified sampling, you have to say what is the basis on which you want to do the stratification. Here the basis is outcome. Correct? So far fine? Everybody? All good? Yes
So
or no?
this is
Yeah.
This is just one training and sampling test, but we can do a rotation wherein values can be rotated and multiple such training and testing sets can be created within the same data set.
Then you are getting into something called random forest, where we have multiple decision trees.
Yeah, I mean, keep the same proportion of testing versus training, but keep shuffling the value so that the overall modeling can be done on all the data points rather than just keeping a specific set for testing.
Now that you can do, but then the point is that finally the model has to arrive at one set of conditions, right? One equation.
Yeah.
On what basis which samples equation it will take?
Yeah. So k-fold optimizations is normally that people do. I mean, but that is about the division of the entire data sets into multiple, right?
No, this one also you can do, but then you have to do something called random forest.
Yeah.
Or so where you have sorry, not random forest. Random forest is for decision tree. There here you have to do multiple regressions. Okay.
Hmm.
And multiple regression equations and combine the regression equations into one, taking weights from different regression equations. So these are little more advanced methods of how you minimize the error. Yes, if you intend to be a data scientist, you need to know those methods. Okay,
So
Avinam.
what I mean to say, yeah, I agree, sir. I agree. But the point is, even as a manager, we'll have to ensure that the data which is being taken for creating a model has to be absorbed in a proper way. I mean, one person can just take a 70-30 division and prepare a model out of it. But if the manager knows that this all can be rotated and I mean, better fit can be provided, that would be more useful.
Yeah,
It's
yeah.
just my
See,
opinion.
I always believe you are a better manager when you know the technology. Okay, that is universally true.
Yeah, sir. Agree.
Okay, universally true. I will if I know automobile technology, I'll be a better manager in managing automobile company than managing a tobacco company. Okay. So that's true universally. So what you're saying is that yes, of course, as a manager, more technically sound I am, better will be my decision. So yeah, so let us go back and let's do the next step. Okay, so partitioning, what we'll do, the configuration we are going to do, we are going to do the stratify sampling based on outcome and apply this. And now you will see that there are two partitions. One partition consists of 537 data points. Second partition consists of 231 data points, and each of them has been sampled with stratified sampling. Everybody clear?
Yes, sir.
Right. Now that we have done the division, what we need first is to train the model. And we are going to train the model on, let's say, logistic regression. So we need something called logistic regression learner that will learn from the data. And the output of the learner will be a model, that means an equation. Then this equation will be subjected to the other data set, which is a test data set. And there'll be something called predictor. The predictor node is going to use the model to predict the test data that is provided. And then we will find out what is the accuracy of that prediction. So what we need to do is we need to get something called logistic regression learner. Okay, so you see here logistic regression, this thing is logistic regression learner. Take the first partition into this. And not much required in the configuration except the fact that you have to say that which is my target column. And let's say my reference category can be both 0 and 1, but let me consider 1, assuming 1 is diabetic. And what are my features? Now, if there is any feature you think we should not be included, I can take it to the left. And there are cases where certain features may need to be excluded. Okay. But in our case, we don't need to exclude any feature. So we'll keep all of them together. Okay. And there are few statistical things like what kind of something called gradient uh, basically you try to find out the minimize the sum of squares, and that is called gradient. You are minimizing the error. So it is as if you are kind of coming down the hill and you're taking the path which takes you the fastest to the base camp. Okay. So this is called a gradient descent method. And again, these are little mathematical and statistical terminologies. At this stage, probably you don't need to know that much of detail. But is everybody able to see this, or you are not able to see the pop-up? Are you all good? Yes or no?
Sir, again, half a pop-up is.
Okay, pop-up is not there. Okay, great. No problem. Are you able to see the pop-up?
Yes, sir.
The reference category 1 and the target column is the outcome. It has automatically chosen because that's the only string value that we have. Everything else is numeric value. And we are going to take all the features. In case we wanted to exclude some feature, we could have put it on the left. But in this case, we are going to include all the features. Let me know if I've got this.
Sir, what is reference category here?
Reference category is basically it is trying to say that which one I will be interested in. We'll talk about something called confusion matrix. So in the confusion matrix, there's something called positive class and negative class. Okay. So which one will be considered as a positive class? Will I consider diabetic to be positive class? Will I consider non-diabetic to be positive class? If I chose 0, that means non-diabetic would have been positive class.
So there's an option of stochastic weighted execution or maybe iterative weighted action.
Yeah,
Which
so
one
you
is
can
to be
leave it
taken,
as
or by
stochastic.
default we are going?
Yeah. No,
Okay,
you can leave it as stochastic. Right? Leave it as
Okay,
stochastic.
okay.
See, these are called hyperparameter tuning. Okay, that means a statistician would figure out what would be the best option to go for. And sometimes it can be figured out scientifically, that means physics based, and sometimes it has to be database. That means you have to run it for both and figure out which one is giving you better results. These are called hyperparameter tuning. But for us, we don't need to get into that detail. Again, these are all details that those of you who are interested in data science, you should do a course on data science, which will typically take you through all these details. And especially those who are into technology field, these kind of courses today, data science, Gen AI, okay, they are kind of becoming imperative to take any managerial decision. So we'll just run this. Okay. So it has given me some warning. It did not reach a convergence. So it is basically, it has number of iterative methods. So it is saying that it did not reach a convergence, meaning it did not necessarily find out a line where the sum of square error is the minimum. Okay, so but within the data set, it did not find a global minimum, it found out a local minimum. Within the options that it tried out, it found out which line is minimum. But it is not promising that there is no other line where the sum of the squares can be less than what it has found out. Okay, so this is where you have to again run multiple epochs. Epochs are multiple cycles to figure out what is the best line. Okay, but as of now, we may be happy with whatever line has been given to us. So far, fine, everybody. Okay, all good.
Yes, sir.
So there are certain other statistical terminologies. I think at this stage we don't worry about this. We'll go to the logistic regression predictor. What is the predictor going to do? Predictor is going to take the model, pass it to the test, and give us an outcome which we can compare and say how much the model has been accurate. So take the blue input over here and take the other one, which is the test, and put it over here. Configuration, you can append columns with predicted probabilities. Now remember that I told you that I'll ask you a question or rather comment on a statement where I said that classification problem is essentially a type of regression problem. Okay, so we'll move towards this question very soon. Is everybody okay till now?
Yes, sir.
Great. So we'll execute this. Now, once we execute this, you will see that it has predicted. So you see, this is the actual outcome, and this is a predicted outcome. For example, the first outcome was 1, it has been predicted as 1. Second outcome was also 1, actual outcome was 1, the prediction is also 1. Okay, I like that. But in some cases, you see there's a discrepancy. The actual outcome was 1, but the prediction is 0. That means actually the patient is diabetic. But if I follow this model, if this model was to predict, the model would have predicted that the person is non-diabetic, which is an error. So obviously, we have to figure out how many such errors are there. And how is this model figuring that out? The model is figuring that out by getting a probability. The first one is what is the probability of the outcome to be 1, which is 0.623 in this case. Okay. Another thing that you have to note that each one of you may get different results. Each one of you will get different results because the sample that each one of us have is different. We have just asked to divide 70-30, but which set of numbers is getting into training set and which set of numbers getting into the testing set, for each one of us may be different. Okay. So here, for example, is saying that 0.741, the probability that the outcome is 1, that means the patient is diabetic. And the remaining 0.259 is the probability that the patient is non-diabetic. Now, what it is doing is that it is finally the outcome is diabetic or non-diabetic, and it is taking a cutoff. The normal standard is to take a cutoff of 0.5. That means if the probability for being diabetic is more than 0.5, it will be considered as diabetic. Patient will be considered as diabetic. If the probability is less than 0.5, it will be considered, the patient will be considered to be non-diabetic. So I take a cutoff. Probability above that will be diabetic. Probability below that will be non-diabetic, or 1 and 0. Is this concept clear? Yes, no? Have you got this in the first place? You may not get exactly the same values.
Yes, sir. Done.
Okay, done. Great. So can you now comment on my statement that classification problem is a type of regression problem?
Yes, sir. But with a tagged outcome, like kind of a multi-valued outcome to be predicted, not a
Yeah,
continuous value. It has to be a discrete multi-valued problem.
No, if it is discrete multi-value or two values or multiple values, then it is not a regression, right? But why am I saying, or do you support the statement that classification is nothing but a type of regression?
Indeed, it is. Yes, sir. I agree.
Okay, why is it so? I mean, if it was a a set of values 1 or 0, then it is not regression. Okay, then it is kind of classified. But then why are we saying that, or why are we supporting that it is a type of regression?
So because it is the model is predicting the value between 0 and 1. It is in a
Absolutely
decimal.
right. Absolutely right. The model is not predicting 1 or 0. The model is predicting a probability. Now, on top of that, an assumed cutoff is given, 0.5. And then there's an artificial cutoff. If it is more than 0.5, you're classifying as diabetic. If it's less than 0.5, classifying as non-diabetic. But model is not predicting whether somebody is diabetic or non-diabetic. Our model is only predicting the probability of being diabetic and non-diabetic. So that's why the outcome is just a probability, which is a value between continuous value between 0 to 1. And that's why a classification problem. So all classification models essentially gives you the probability, and then you apply a cutoff. So that's why all classification problems are essentially regression problems. Okay, so far fine, everybody? So now we need to figure out how accurate the model is. And here that is, I mean, we have to measure accuracy from various perspectives. So it's not just how many times the actual outcome was 1 and the model has predicted 0, because the reverse can also be true. How many cases the actual outcome was 0, but the model has predicted 1. Okay. So what we enter, maybe a few other things that we need to know. What we'll do, we'll use something called a scorer. Scorer will collect this data and give me some important metrics. So in the scorer, we'll just configure and say that I want to score the actual outcome against the predicted outcome. Actual outcome against the predicted outcome. First column is actual outcome and the second column is predicted outcome. Okay. And then I'll execute. Moment I execute, I get something like this. And this is called a confusion matrix. What is giving is, and note that the numbers will be very different. Okay, your number will be very different from my number. Because all these models are non-deterministic because we have taken different samples. Okay, so what does this mean? So let me just, so as first of all, has everybody got this?
Yes, sir.
Yes,
Right.
sir.
Yes, sir.
Anybody is aware of this term called confusion matrix?
Yes, sir.
Okay, so what does it mean?
Sir, it has a combination of the actual results, which are true in full sense, and then we have false positives and false negatives. From there, we
Right.
find out, how efficient the model is.
Right. Yeah, broadly correct. But in the interest of everybody, let me just repeat. But again, everybody has got this. Anybody has facing any problem?
No, sir, got it.
Got it. Great, Asha. So let me just stop the share. Okay, so first of all, as I say, that we have to define which one is a positive class and which one is a negative class. We have defined the, so we are trying to decipher this confusion matrix. As the name suggests, it's quite confusing. That's why it's called confusion matrix. It's not difficult, but it's confusing. So first we have to define what is a positive class, because all our metrics will depend on which value we have classified as positive class and which one we have classified as negative class. And that's why I remember that I changed this for the in an earlier note. I changed the 0 to 1. Okay, so our positive class is 1, which means diabetic, and our negative class is 0, which is non-diabetic. Now we have got a result like this. Let me put the numbers that I have got in. I have gotten 43, 38, 10, 140. 43, 38, 10, and 140. Okay. Now, first of all, if I look vertically, what I see is what has the modulus predicted. And this is the positive class, which in our case is 1. And this is the negative class, which in our case is 0. So the model has predicted this way. And if I look horizontally, this is what actually has happened. So positive class is again 1 and negative class is 0. Now, what does this 43 mean? Can anybody interpret, or can anybody kind of make an English statement based on this matrix for this 43? What are these
Sir,
43?
this is positive class correctly detected.
Right. So 43, there are 43 instances where the model has predicted that the person is diabetic and actually the person is diabetic. That means the model has predicted correctly the diabetes. So this is called a true positive. Now you see why it was important to mention what is positive and what is negative. Okay. On the other hand, if you look at these 140 cases, these 140 cases are those cases where the model has predicted that the person is not diabetic and the person actually is not diabetic. Because remember, we are testing the model. The model does not know the outcome, but we know the outcome and we are able to compare. So this is called true negative. Okay. True positive and true negative are the cases where the model has predicted correctly. But where the model has predicted incorrectly, there are two types of incorrectness. What is the first type of incorrectness? The first type of incorrectness is, let's say, this 38. Can anybody kind of state in English what is this 38 mean here in this case?
Sir, model predicted 38 times that the person is non-diabetic, but in actual it was diabetic.
Actual, that means this was a negative case. The model has predicted that is a negative case, but actually it's a positive case. So it's a false negative. Falsely, the model is claiming to be negative. Okay. On the other hand, there are 10 cases where the model predicted that the person is diabetic, but the person is actually not diabetic. This is false positive. Falsely, the model is claiming to be a positive case. Now, here is the question. The first question is that one way to measure the effectiveness of model is to find out what is the proportion of cases where the model has correctly predicted whether positive or negative. So that means I can find out how many times the model has done two positive and two negative divided by the total population. It is two positive plus two negative plus false positive plus false negative. So this is one simple measure to calculate how accurate the model is. How many out of the total population, how many times the model has correctly classified positive classes and negative classes. Correct? This is called accuracy of the model. But this is not good enough to assess the the effectiveness of the model. Why? The cost of error may be different for a false negative and a false positive. So in this particular case, which error do you think is more expensive for the model, for the subject? False negative or false positive?
False positive, sir.
False positive, that means where the model has predicted that the person is diabetic, but actually the person is not diabetic.
Yeah.
Do you think that is based on common sense? Is that something that is more concerning compared to if the model has predicted the person is not diabetic, the person is actually diabetic? If I am diagnosed that I am diabetic, but I'm actually not diabetic, what might happen? I mean, as long as it depends on how acute the diabetes is, but usually what happens is machine learning applications at a very early stage. Okay, so at a very early stage, probably I've seen I've been diagnosed diabetic, but actually I'm not diabetic. The doctor will tell me, okay, control your food, take less sugar. Probably that will not cause me so much of harm, isn't it? My food habit probably will become better.
So it
As
depends
opposed
what we are
to,
going to do with the data.
sorry?
It depends on how we are going to use the data, the outcome data. Suppose
Not only how
somebody is
you're doing.
diabetic and
Yeah.
the algorithm says the person is not diabetic.
Mm.
So it will be missed out. So we
Yeah.
may not be able to provide the good medications to the person. Maybe the situation may worsen. But if a person who is not diabetic and is being treated as a diabetic person, not necessarily that the doctor will be advising good food and all. They might actually prescribe the person a strong medication in that case. It might harm the
Strong, yeah.
person. So it depends.
Insulin and that might. Okay. So how do
Yeah.
we mathematically solve that problem? So you have to mathematically solve that problem, right?
Yeah.
How do you do that?
So we may have to see, but
You have to see the cost of error. What is the cost of error? So you have to define something called a cost function. So if the use case is that this model is going to be used only to check some very basic pre-diabetic cases or very early diabetic cases, then automatically the cost function will show that the cost of a false positive is much less than that of a false negative. Okay. But if this model is to be used for heavily diabetic patient, you may see that the cost of false positive and false negative may be equal, or even the cost of false positive may be higher than cost of false negative. So I have to define a cost. So this is where management comes in. Because the data scientist's job stops over here. Data scientists cannot get this cost function. So as a manager, you have to define the cost function. And situations may be different for different cases. Let's say instead of this medical condition, my use case is that of, let's say, predicting customer churn. Let's say you are working in a telecom company, you are trying to predict whether a customer will churn from your company and move on to another service provider. There also, there'll be false positive and false negative. False positive, let's say the positive class is the customers who churned, and the negative class with customer who did not churn. So the positive, so false positive is that the model predicts that the customer will churn, but the customer actually will not churn. And false negative case is the model predicted the customers will not churn, but the customer actually will be churning. So it depends on what kind of intervention you are going to do. Suppose you are saying that you are going to have some retention intervention. Let's say you are giving 6 months subscription free to retain such customers. The cost of that subscription. Now you have to figure out which one is more expensive. Giving the subscription free, or for example, if a customer leaves, getting another customer, the cost of acquisition of a new customer in place of an existing customer who leaves you. The concept of customer lifetime value also come in, because if a new customer comes in, will the new customer will have the same lifetime value as an existing customer leaving? There, a data scientist will not be able to solve that problem. Okay, so there's an entire new discipline on the managerial aspect of data science, where the data scientist gives you this data, and from there you have to figure out whether, you know, what will be the cost of retaining a customer. Okay, and whether on how you know, which one you would like to optimize, whether you like to optimize the false positive or the false negative. That makes sense? Yeah.
Sir, any scenario where you can give an example of where cost of false positive is higher than a negative and vice versa?
Cost of false positive higher than the, yeah, we saw in this scenario itself, right? If we are trying to, yeah, if you are trying to use this model for early diabetic cases, the cost of false positive is much less than that of false negative. But if you
So
are,
a case of cancer patient could be a very apt for this one, where false positive might have a bigger impact.
false positive might have a, again, it depends on whether it is at the early stage or late stage, right?
Yeah, correct.
They both can have an impact, right? If you have wrongly diagnosed cancer, there's an impact. On the other hand, if you have diagnosed cancer and actually the person is not having cancer, that also has a, that may have a big impact.
But again, I mean, coming back to your point of cost of error, I mean, it really depends on cost of error, whether the case is
Right.
severe or not.
Right.
And how much is that error? I mean, how much is the cost of that particular action to be taken, whether to go for it or not?
Absolutely. Absolutely. And that's where the business input has to come in to determine the cost of error. So there are a lot of research papers on this, that how to define the cost function.
Sir, could
Again,
this cost function be is it similar to what we say penalty in case of the neural networks? When the wrong decision is taken and you based on the cost function, you say you take penalty.
Yes. This is equivalent to penalty. That's right. And the input to this penalty has to come from business. For example, a business will determine what is the cost of treating a patient who does not have cancer as a cancer patient, and what is the cost of treating not treating a patient who has cancer and ignoring that cancer. What is the cost of that? Okay. In case of medical, the cost can be high in both cases because both are dealing with life. But in case of some other situation like customer churn, okay, the cost of customer churning, where you are, let's say you have predicted that the customer is going to churn when the customer actually is not going to churn. Are you going to do some intervention or leave it as it is? If you are going to do some intervention, what kind of intervention? What is the cost of that intervention? That value has to be put, and calculating that value is not easy. On the other hand, if the customer, you're predicting the customer will not churn, and actually the customer churns, that means you are not going to do the intervention. So what is the cost of losing that customer? Again, the calculating that value is very complex. Because you have to take into account what is the customer lifetime value. Whenever you are losing a customer, what is the customer lifetime value? When you are replacing the customer with a new customer, does the customer have the same lifetime value? What is the cost of replacement? Okay. Okay. Any other comments, questions, Usha or anybody else?
No, sir, not at this point.
Great. Okay. By the way, just to the technical terms for these two errors. One is called precision. Precision is out of the predicted positive cases, how many are actually positive? Out of the predicted positive cases, how many are actually positive? That means true positive divided by true positive plus false positive. The other one is recall. This means that out of the actual positive cases, how many have been predicted correctly? That means this is equal to true positive divided by true positive plus false negative. Essentially, what we try to do is we try to either improve precision or improve recall based on which one for which the error is more expensive. Usually, you cannot increase both. If you try to increase one, the other will fall. And that's why you need to do a trade-off. Okay. So far, fine, everybody?
Yes, sir.
Great. So I think that helped to, I hope that this helped you to give some idea about what kind of applications we'll have for machine learning. Next class, we are going to get into another very interesting area, which is the entire area of IoT and sensors and all, and how do they apply for your industry 4.2. Okay. But of course, as far as NIME is concerned, you can try out many other things, and that will help you to get a grip on some basics about machine learning, which is very, very important in today's world. So far, fine, everybody?
Yes, sir.
Great. We close the session now, and I'll see you again next Sunday. Okay. So bye,
Okay, sir.
everybody.
Thank you.
Bye, bye,
Yeah,
bye,
thank you.
bye, bye.